Hello, everyone. Good morning, and I would like to welcome you again to our webinar session today. I'm Elvin from Moldex3D European team, and the topic for today is compression molding analysis workflow in Moldex3D Studio with our latest version R17 that is scheduled to be officially released in Europe soon. Okay, so here's the content for today's webinar session. Uh, First, of course, we'll have a basic introduction about this module, about this molding process. And then I'll be talking about the compression molding workflow in R17 Studio to have a quick preview. And then I'm going to show you some video demo so you can have a better look of what it actually looked like in our studio interface and how to actually operate it. And finally, we'll have a short conclusion to conclude the day. Okay, so let's get started. First of all, the introduction. So compression molding is one of the simplest way to make rubber products, and actually not just for rubber material, but also a lot of thermoset and thermoplastic materials can be used. And this process is like we put either it's a powder or it can be a sheet molding compound or in other forms. Either way, we put the charge in the mold, and then it will be the mold closing, which is the compression stage, and we'll form the part. And after that, we let the polymer go through a packing stage or a curing stage. And after that, is the mold open and take the part out. We get the final product. But for a lot of thermoset material and for rubber material, of course, a lot of the times we'll have flash along the parting line for the final product, and that's when we need to trim the flash and in order to have a fine final product as we wish. And in a lot of the products nowadays, compression molding is still the best molding process for certain products, especially for large parts or large, plain, relatively uniform and less small features products. Okay, and in Moldex3D, our compression molding module supports a wide range of materials. We can run a simulation for thermal set, including bulk molding compound and sheet molding compound. And as for a thermoplastic material, it can comes with a pellet or a sheet. And of course, elastomer and rubber-like material. Okay, and here are some important factors that will influence a compression molding product. Okay, and there will be three factors. Number one, of course, is the material itself. So the material properties like the viscoelasticity, the viscosity, and the PVT curve, etc. And if it's a fiber reinforced material, then the anisotropic behavior that is caused by the fiber orientation is also has a great impact on the final product and its deformation. So this is number one, the material property. And then number two is the part design, the geometry. So the part thickness and some features on the part, how we put the charge location, and how the charge is actually shaped, and whether it's a single charge or multiple charges. All these geometry design can influence the melt front, the filling pattern, and of course its final product. And then number three is from manufacturing point of view, the mold wall heating, the temperature control, the closing range, the machine clamping force, the preheat time, demolding time, and of course the compression force, the pressure, etc. So from a manufacturing point of view, all these process condition can influence the quality of our product. So these three main categories, they all have great impact to our product quality. And it can be very difficult to consider all these based on our experience, which is why we need simulation. So Moldex3D compression molding module, this is what we can do. We support both thermoplastic and thermoset materials, as I mentioned before. And during the compression stage, we can do a filling and packing calculation. And then cooling, finally, we calculate the deformation, which is the warpage analysis. And if it's a fiber reinforced material, we support fiber orientation analysis, and we consider the fiber orientation and put it into our warpage control calculation and calculate its influence on our deformation. And if we were talking about an optic part, we can also consider the residual stress analysis with the viscoelasticity property of the material. And after the calculation, we can output the flow rate information, and it'll be in our filling log. So in reality, we'll know how we can properly set up the machine, how we can control the compression force, the flow rate profile, etc. And Moldex3D supports parallel computing. This can greatly enhance our calculation performance, which means we'll require a much shorter calculation time if we use multiple cores of the computer to do the calculation. And finally, Moldex3D is capable of reading the deformation information from LS-DYNA. And this is especially for sheet molding compound. Because for SMC, the beginning stage of a compression is more like the polymer is still at a solid stage. Now, Moldex3D is specialized and very powerful in fluid dynamic wise calculation. But in the beginning stage of SMC compression molding, it's more related to solid dynamic in the beginning, which is why we recommend this kind of workflow, that for SMC we start with LS-DYNA to calculate the large solid deformation in the beginning stage. And after the sheet molding compound is largely deformed and it has a shape that is closer to our mold surface, and also it has reached a higher temperature that is more of a fluid stage, then we can export this data from LS-DYNA, import it into Moldex3D, and continue the calculation and finish the whole compression molding process for sheet molding compound. But that will be another workflow, so we will not focus that today. And as for today, we'll be more focusing on like rubber material, thermoplastic, or if it's a bulk molding compound. So it'll be more like our workflow today. Okay, so in previous version, up until R16, our old way of preparing a compression molding simulation is we need to use two different applications to finish the pre-processing and post-processing. So number one is in Designer, or if we need to build hybrid mesh. For example, we're having a optic part, then it is highly recommended to use complete prism mesh. Then we have to use Rhino. So it can be either designer or Rhino. In either of these two applications, we will prepare the model and we set up the compression surface, compression zone, and we complete the cooling or heating design. And finally, we mesh it. And after that, we will export the mesh file and put the mesh file into Moldex3D project, which is on the right. And then in project, we can set up the process condition, we set up the compression charge, and we start the calculation. After the calculation is finished, we can do the result interpretation. We review all results and predict the potential defects of the part. We find out a corresponding solution, etc. So we do it in Moldex3D project. So this is the previous workflow in previous version of Moldex3D. So for today's main topic, compression molding workflow in R17 Studio. We have integrated pre-processing and post-processing into a single platform, Studio. So in Studio, we can prepare the part right here, and then we can set up the compression zone very easily with a very smart tool that we'll take a look at the detail later on in the video demo. And we have some smart tool for users to select the compression surface. Okay, so this is set up compression zone in Studio. And then we can choose what kind of mesh we want to generate. And by that, I mean solid mesh for our compression zone. So it can be either prism mesh, which is recommended. But if we cannot generate prism mesh, then which is like this case on the right, because as you can see, we have a vertical edge over here. And if this vertical surface, we want to extrude it directly upward, and in the end, we might end up with a very, very sharp and narrow solid mesh for this vertical surface, which is why in this case, prism mesh is not recommended. Then we can choose to generate BLM mesh. And then either it's a compression molding module, or in this case, we have runner because it's injection compression molding. Either way, we can generate the solid mesh for everything simply by one click. So this is the automatic meshing technique in Moldex3D. And after we finish the mesh, we don't have to switch to another application. In Studio, we will be able to set up the charge, as you can see on the picture, and then run the simulation. Okay, so this is how the workflow roughly looks like. And after that, after the calculation is finished, we will be able to use the powerful post-processing tools in Studio to view the results, to spot some potential defects and come up with possible solution for the part. Okay, then in the next part, we'll take a look at our video demo for today. Okay, so this is what Moldex3D R17 Studio interface look like. And in the beginning, we have to start a new project. And we can set up the project name. We can choose where the location we want it to be saved. Okay, after we've created a new project, um, as you can see, we're using a ribbon style design for Moldex3D Studio. And it's basically, we just follow everything from the left to right. So in the home, we can choose what molding process we want to use. And then we can prepare the model, we can mesh it. And there are some useful tools for us to help us prepare the model. And then after that, we can set up everything and run the simulation here and view the result. Okay, so for today, we will choose compression molding process. And then we need to import the geometry, which is our part. We can do it in the Home tab or do it in the Model tab. They're actually the same. So now I will import the part. After it's successfully imported, we can double click it and easily set up the attribute as part. Now, if we have mold base, if we have cooling or heating system, or some inserts, we can do it at the same import at the same time, right? Like right now. And if we have, if it's injection compression molding, we can set up gate. If we want to build up a complete mold design, including cooling and heating system, we can do it right here. As I said, we follow from left to right. And as for the demo today, we'll skip that and just set up a compression zone. So on the right is compression zone. And here we can set up the stroke length, which is the compression gap. So immediately we'll have a quick preview of what our compression zone should look like. And then we have this useful tool, this is the face angle. We can use mouse to drag it, or we can actually just type in the exact number. So this is a smart snap tool for all the users that you don't need to select the compression surface one by one. Okay, and if after you select a proper angle, there might still be some small surface that you don't want it to be your compression zone, you can use remove and just delete them simply by clicking them. Okay, then as you can see, very easily the compression zone has been properly set up. Then we go to the mesh stage. First, of course, we have to do the node seeding to determine the mesh size for this part. Moldex3D will calculate a default mesh size based on the part average thickness. So the default value will be twice your average thickness. This rule remains the same for compression molding, injection molding, and other molding processes. So for a small part like this, we actually suggest users to use half of the default size, or sometimes even quarter of it, because for this part, the length is about 5 centimeters, so it's a relative smaller part. Okay, and then is the solid mesh setting. So on the top, we have the solid mesh setting for the part. We can choose how many boundary layer we want. And on the bottom is the solid mesh for our compression zone. And as you can see, we have pure tetra, full prism, or boundary layer mesh for users to choose. Now, generally speaking, we recommend users to use prism if possible. And then we have to decide the layer count is the layer of prism mesh along the thickness direction. So you need to use different number of layers based on your stroke length. So higher the compression gap is, more layers that you might need. Okay, and after it's determined, we can go and generate the surface and solid mesh for our part and compression zone. And normally this step will take maybe 1 to 2 minutes. But for a small part like this, generally speaking, is less than 1 minute. Okay, so now that the solid mesh for part is done, we'll extrude the prism mesh for compression zone. Okay, now that the mesh is done, we can go to final check. And Moldex3D will check the mesh quality and to all the solid mesh is acceptable for the solver to properly finish a calculation. And if the mesh quality is okay and the whole model, there's no problem with the whole model, Moldex3D will save the mesh file. And after that, it will lead us back to the Home tab so that we can set up the charge, our process condition, and etc. Okay, so now the mesh file is successfully saved. We just click on OK. As you can see, automatically we're back to the Home tab. And here we can set up a charge. And before we set up the charge, we need to import our CAD file for the charge. So if we hide the compression zone, we'll see the chart right here. Right now it has no attribute, and we can go to the home page and click on the charge icon, select, and then right here we have the charge already set. And if we have some extra boundary condition like venting location or some fixed constraint we want to use, we can put it. And then as for material, if we want to find a material in our material wizard, that's what we can do. Or we can choose the material from the user bank or just some material that recently used. And automatically, we will give you a default process. And if you want to modify it, just click on Process Wizard. And here we can modify the compression time, compression speed, compression force, and the temperature. And all these process conditions can be manually set up by the users. And then we can choose the analysis sequence, like either we just want to run a filling to look at the filling pattern or the injection analysis, including filling and warpage. And if we have built up the complete mold design, then we can also run a cooling analysis to look at the temperature distribution. And finally, we just click on this run icon, and then we can start the calculation. Okay. And then after the calculation is finished, right now we'll take a look at some useful tool. Like for example, we can play the melt front animation, so we can easily look at how the filling pattern will be. And we also have a lot of other results like the shear rate. And with some tools like clipping, we will be able to look at the cross-sectional view of almost all the results. And also we have slicing, so we can have multiple slicing planes that we can look at. And apart from the filling results, we also have warpage calculation. We can look at the deformation. And for deformation, we also have this deformation scale that we can scale it multiple times, so we can easily look at the warpage trend of how the part is actually shrinking and bending. And also we can use probe, put the probe at anywhere we want on the part or inside the part, and immediately we can take a look at the exact value on the certain point. And the measure distance functions allow us to get the distance, the deformed distance uh, between 2 points immediately. And also we have compare runs. So under compare run, we can sync the angle. So we rotate it. They are rotated at the same time. And we can take a look at different results in the same run. Like we're looking at right now, it's the same run, but on the left, we can take a look at the deformation. On the right, we can take a look at pressure, volumetric shrinkage, etc. Or if we have multiple runs, we can look at the same result in different runs. So let's say we have different compression speed, and we want to know how the compression speed influence our feeling pattern, influence our pressure. We can run multiple simulation and compare them at the same time. Okay, so this is some post-processing tools in Studio. So as you can see in the video demo, we have integrated pre-processing and post-processing into a single platform. Now, I would like to focus a little bit on some useful tools, because in the previous version, when we set up a compression zone, the way we did it in the past, it was not that, frankly speaking, it was not that user friendly. But in Studio, the compression zone setting is much easier, much faster, and much more user friendly. So after we have imported the part, like we did in the previous video, and we can go to the compression zone setting, select the object, and automatically, based on the geometry, we will give you a default compression direction. And we can manually type in the compression vector as we wish, like right here. Or if we have sketched a compression direction with a curve in the CAD software, or either you sketched it in Studio, you can do it either way. Like for example, right now, we just sketch a curve and assume this is the actual compression direction. And we can use mouse select on the two ends of the curve and define it as our compression direction. Okay, so right now we'll put the direction back to the normal value. And then is the stroke length, which is the compression gap. And then the most important thing is this smart snap tool, the face angle. So larger this number is, the more this compression surface will extend to. So all the surfaces that is within this angle will be considered as the compression surface. So we suggest users to set up a proper value that covers most of your compression surface. And then we can use the edit tool on the bottom to add or remove some of them. So we'll take a look at all these. So first one is to select a single poly surface. Or this one, we can window select. So if we go from right to left, all the surface that is touched by this rectangle will be selected. Or we have also circular select tool. And then this second one is the diffuse. So all the surface that is within this angle, so if we select this surface, all the surface next to it that is within 10 degree will be selected and will be added or removed depending on which one you are using. Okay, so this is a smart tool to easily set up compression zone. So right now I will quickly generate the mesh and then we can take a look. So what we're going to show you right now is, in the past, after we set up a compression zone and we successfully generate the mesh for it, and what we said is it is already determined. It's done. So basically it cannot be modified. But it's not the same in Studio. So if after mesh generation we double check this compression zone mesh, and it is actually not what we want, not what we desired, and we want to modify it, we don't have to start all over again with the model. We don't have to import the model again and manually select all the compression surface all over again. We just have to go back to the compression zone right here, and we will Moldex3D will automatically delete all the solid mesh for you, and the original compression zone setting will be saved. So as you can see, everything is saved right now. And if there are some extra surfaces that you want to set up as compression zone, or there are some surfaces that you don't want it to be compression zone, you can use our tools down here and easily modify our compression zone compression surface. And just click on OK, go back. You don't have to generate everything all over again. The surface mesh will be saved. So if you have other things like part inserts, mold inserts, we don't have to worry about that. And then just regenerate the solid mesh, and that's all. So unlike our previous version, in R17, we can easily set up, and after we have set up the compression zone, we can easily modify it without having to start all over again. Okay. And then another tip is, after the mesh is successfully generated, and let's assume that this setting is exactly what we want, and then we'll go to the charge setting. So now we have some useful tool that we can use when we're trying to set up a charge in Moldex3D. So first, of course, we import the charge CAD file. So we hide the compression zone. So now, as you can see, we have a charge right here. We select it, click on OK, and Moldex3D will calculate the volume of the charge and the volume of our part. And if the charge is too small to completely fill this part, or if it's too big, we'll give you a warning message. So right now it's 144, but what we need is actually at least 223 cc for the charge. So we can close it, and instead of going back to our CAD software and scale it or even resketch it, in Studio we have this smart scale tool that we can scale this charge either 1D or 2D or 3D scale. So as you can see right now on the screen, first we pick a scale reference point. So let's say on the bottom surface of this charge, and we can scale it uniformly, which means 3D on all three directions, or non-uniformly. So on each direction we can have different percentage, different scale percentage. So for example, right here we can put 40% bigger along the X direction, and immediately we'll have a preview. Or if we change it back to uniform scale, and since Our part is 144 and it needs to be, let's say, 80% bigger. So we'll give it 20% bigger on all three directions. So this is our new charge. And we just have to go back to the Home tab, click on the charge setting again, and select the object, click on OK, and let Moldex3D recalculate it. And as you can see right now, the charge is slightly larger. So this step is actually very important because if we forget to go back and reset it, let Moldex3D recalculate the volume again, then sometimes we might end up with a bigger charge, or maybe like even still too small of a charge. So now we properly scale it and click on the charge setting again. And as you can see right now, there's no warning message, meaning the charge volume is proper. And we just have to show the part and compression zone again to double check if the new charge we have right now is still within the compression zone range. Because if after we scale it is too big and it's going outside or going out of the compression zone, then we might need to modify it a little bit. Okay, and if everything is okay, that means we have properly set up the charge. So these are two tips and let's say new functions, new features in R17 Studio for compression molding that makes this advanced module a lot more user-friendly, much easier to use. So now we will go to the conclusion for today. Moldex3D R17 Studio integrate the pre and post processing into a single platform, and users can easily set up the compression zone and compression charge, which is shown in the previous video demo, those two tips. And with the automatic meshing kernel, we can mesh everything with one click, and this can greatly shorten the pre-processing time. And after the calculation, Studio has a powerful post-processing tool that makes result interpretation much easier for all our users. Okay, and that will be all for today's session, and thank you all for your attention.